troubleshooting the Ural start system and the kill system. This is a wiring diagram off of a 2006 Ural. You can do it with any year. Just make sure you have the right wiring diagram. The systems really haven't changed that much, so all you have to do is trace things out. First, we'll start with the kill switch to show how it provides power to the key components and how it is able to turn the engine off. So the 12 volts for the kill circuit comes out of the fuse panel here, and if you follow this wire, it's going to go around and it's going to go to the instrument cluster up front. That's the neutral indicator, that's the battery light, and that's key right there. Remember the battery light. The 12 volts goes up to the right hand switch cluster on the handlebar, goes into pin D, comes out of pin D and goes to one side of the kill switch. When you turn the kill switch on, it lets the 12 volts come out the other side to pin E, comes out of pin E, and you follow this red wire along. It provides 12 volts to your ignition system, the coil, and the CDI if you have a Ducati ignition. I have a Ducati ignition in mine, but type 5 if you have the standard 2006 ignition. 12 volts taps in to the alternator down here, and then it continues on to the energized side of the start relay. Now that's another key component. The 12 volts also goes up to another leg of the start relay, and if you can see in the de-energized position, the 12 volts just sits there on that leg. But we'll keep that in mind because that'll be worked on the start system. So again, when you flip the kill switch to on, it energizes your ignition system, and it's sitting on the start relay waiting for you to hit the start button. So when you turn your key on, it provides 12 volts to this fuse, which again is going to the kill switch, and it sits on one side of the battery indicator. Now that's key because when you turn your key on, any system needs a ground in order to work. So the start system ground actually comes from the alternator. It's one of the small wires that is hooked to the alternator, and the ground is sitting there as long as the alternator is not spinning. So you have a ground that comes here, and it goes to the other side of the battery indicator. So if you turn your key on and your battery indicator is working, you know you have this 12 volts path up to one side of the kill switch, and you know you have a good ground coming out of your alternator. Okay, from there, the ground goes up into pin F, comes out of pin F, and sits on one side of the start switch. When you hit your starter button, it closes, the ground comes down to pin G, comes out of pin G on the other side to the other side of the start relay. You already had your 12 volts there from hitting the big red switch and turning it on. The ground energizes this contact right here, flips that contact over, and it provides 12 volts to your starter solenoid. Now, this is the small wire on your starter solenoid. It energizes the starter solenoid. You have 12 volts from the battery down here already sitting. That's the big red wire on your solenoid, the one that carries all the voltage to operate your starter. So when this 12 volts energizes the solenoid, what it does is it takes this 12 volts directly from the battery, engages and spins the starter. Now what's interesting in this whole sequence, when the engine starts spinning, that makes the alternator start spinning. When the alternator starts spinning, you lose this ground. Once you lose the ground, the battery indicator goes out, you lose the ground up through the start switch, and your starter stops spinning. So it's kind of a protective thing too, so your starter won't spin all the time. If your system is working fine, you should be able to hit if your engine's running, you should be able to hit your starter switch and nothing happens because this ground isn't there. Now a couple of key components when it comes to troubleshooting a start system is, say you hit your starter button and you hear a click, but the starter doesn't engage. More than likely, the click you're hearing is this relay energizing. So if this energizes and your starter doesn't operate, then you either are losing this 12-volt path to energize the solenoid, or there could be possibly something wrong with the wire coming off of the battery up here. But if you want to test to see if your solenoid is bad, all you have to do is take some insulated pliers, needle nose, channel lock, something like that, and jumper from the large post on the solenoid that has the wire from the battery to the other large post on the other side of the solenoid. And if you jumper that and your starter starts, then you either have a problem with the 12 volts coming into the solenoid or you have a bad solenoid. If you do that, you want to make sure that your rig is in neutral, because if it does work, the starter is going to engage and your rig can jump. Another troubleshooting tip is if you push the starter button and you don't hear anything and the starter doesn't start, you could have a bad start relay or connections to the start relay. One way you can test to see if that's an issue is you could take a small jumper wire and you can pull this wire, that's the small wire that goes to the solenoid, you could pull it off and jumper 12 volts directly to that. Again, you want to have your bike in neutral, because if you do that and your starter and solenoid actually are operating and the relay was bad, the moment you touch that 12 volts, that small blade terminal, that starter is going to engage and it's going to try to start the bike. So again, if you do that, if you jumper from the battery over to that small blade terminal and all this works, then you know you have a bad relay or something with this 12 volt path right here is off. So that's just a basic video of how to troubleshoot the start system. And what I'll do with the next video is I'll actually go through those two steps on the bike to show you exactly how all that works.